Those are two. Oh my gosh, yeah. Right. Those are two, though.
This was my sleep.
I know.
I have to test my nails.
I have 3 pages left.
All right, everybody. Let's talk about the mixtures of gases. Thursday. Good question. Nope. Guess you'll find out on Friday. We do a lab tomorrow.
No way.
Uh-huh.
Yeah.
Oh, wait. So that's not Friday? This is good.
Nope. Guys, why does it matter? We're gonna be here, we're gonna do stuff, and then we're gonna do more stuff, and it'll all work out. All right, let's talk about this. Diffusion is going to be a form of random mixing. Diffusion is going to work with any phase of matter, but we're going to focus on gases. We talked a little bit about it in the previous chapter, where we talked about the different phases of matter and how they mix. This is going to be gradual for all phases, meaning kind of random and slow. Effusion, on the other hand, slightly different, and specifically gas related. Where molecules of a gas are going to pass through openings. A lot of times we call them tiny openings, but openings are openings. This is the reason why balloons deflate. All materials, no matter what they're made of, are porous in some way. Porous meaning pores, right? That means tiny openings. So gases are no exception. Gases tend to be smaller, or the smallest of all of the molecules that we talk about, because in order to fly around and to have that ability, you have to be kind of small as far as your weight is concerned, or you have to be at a very specific condition, some temperature, some pressure conditions, etc. In the case of effusion, like we said, this is what happens to your balloons over time. This is why the helium escapes. This is why the hydrogen escapes. This is why carbon dioxide escapes, if you will. The larger the gas, as a general rule of thumb, the slower they will leave. Okay, so size of your gas particle matters. Larger also implies mass, if you will. Not just size, but mass as well. And so on and so forth. All right, next thing we're going to talk about is Graham's law of effusion, because of course there's a way to actually dictate how this is going to happen. I would like to write up here, because I don't like writing below a certain point. That is Perry the platypus. I don't know what to tell you.
Where's that? That's agent
Was there on Friday. He's still there, right? So effusion itself, we just said depends on mass, but also on velocity. So how fast they can go through the openings is going to partially depend on how fast they're actually moving. The velocity is also going to be inversely related to the mass of the object. Inverse. Right? That's what we mean when we say inverse. So if you have a high velocity, you must have a low molar mass. If you have a high molar mass, you must have a low velocity. Right? And this is where we said velocity. That's essentially what it means in mathematical terms. This term means proportional to We used a different method when we talked about gases and the laws of gases, like Boyle's law. Instead of writing something along these lines, we wrote something like that, just to indicate that there's this constant or this proportionality that we could actually mathematically determine. Okay? I will remind you that velocity of a particle is directly related to its kinetic energy, right? So how fast it's going to move is dependent on how massive it is and how, at what temperature we typically find it. Right? You've all seen that formula before. If we are comparing two gases, Graham's law of diffusion says that we can actually set the following relationship to be true. The velocity is the thing that's squared in our kinetic energy formulas. This is at the same temperature. So we can relate the velocities or the masses of two different gases at the same temperature using this particular formula. Okay. More specifically, we can talk about the rate of diffusion. Okay, what is a rate? How fast something happens. Okay, so we can talk about the rate of diffusion of gas A over the rate of diffusion of gas B which will equal that guy. This is a rearranged form of that kinetic energy relation. Okay? Where in this case, instead of saying velocity, we say rate. But it's the same idea. How quickly it moves through an opening over a period of time. Okay? This is Graham's law of diffusion. This rate of diffusion of one gas over another is equal to the square root of the molar mass of the gas over the molar mass of the gas. M in this case is molar mass. So let's do the comparison of two gases. So we're going to use our mathematical principle here. We're going to compare two gases. Okay? So if we want to know the comparison, aka the ratio at which these two are going to effuse, we want to know how fast one effuses versus another, we need their molar masses. In this particular problem, we're going to say that O2 is going to be gas B and H2 is going to be gas A from our problem. All right, so what's the molar mass of H2? 2.016. The molar mass of O2? Approximately 32. If we want to know the rate of H2 over the rate of O2, aka we want to know how fast one is moving versus another, then we're going to take the square root of O2's molar mass divided by the square root of H2's molar mass. I got about 4. 3.98. Make sure you do the square roots individually before you plug them in your calculator. This 4 means that H2 effuses 4 times faster than O2. So Graham's law of effusion gives us is how much faster one gas will move versus another through the same size opening at the same temperature, say 25 degrees Celsius, and so on and so forth. Yes, sir?
So is that first equation for defining like the different velocities of stuff?
This guy? This guy just gives us Graham's law of effusion. We could, in theory, if we wanted to know a velocity of, say, H2, figure it out, but we'd have to be given the velocity of B in comparison. But yes, that is one way you could use the kinetic energy relationship. Yes?
Well, we'd be given that on the quiz.
Of course. You're given every equation ever. I'm not going to tell you you have to memorize equations. The one equation I will honestly continue to forget to give you is the conversion from Celsius temperature to Kelvin temperature. I'm hoping you can do that one in your head. If you can't, we should practice more. All right, that is the end. Yes?
Do we know that the H2 diffuses faster because it's a smaller molar mass?
We also could have said that, yes.
Oh.
We could have predicted that we knew H2 would move faster because it's so much smaller, right?
Okay. Yeah.
But we proved exactly how much faster it would move using this formula.
Oh, okay.
Does that make sense?
Yep.
Okay. What other questions? We good? We're good? Okay. All right. So you have a lab tomorrow. Let's pull that out.
Oh, your labs are so hard. You do so many labs. You
We're
see?
actually excited.
I like
I
labs.
like them.
If you don't like labs, boy, it's either you're going to suck or you do a lab every other day. I love it.
Yeah, my name is James.
Okay. My computer still wants me to restart, and it has been 3 weeks. You will be doing a OneNote. Boys and girls, yes, it is a OneNote lab. The lab itself is uploaded onto Canvas. It's called Boyle's Law. What's that? It is a Logger Pro lab. I hope you love Logger Pro. How many The beauty of the Logger Pro is that it collects data for you, and you don't have to collect the data. Here is the lab. It's called Boyle's Law. It's underneath the daily Q. You have the sections here. You don't need to include any section other than the ones I've listed. So use your lab format handout and do this in your OneNote notebook, just as you have in the past. The lab itself has the instructions. Please remember the rules for writing out procedures. What should you be doing? Shortening it, making it in your own words, please, because this is long. And just remember, with the Lab Pro ones, there are symbols that it'll ask you to click. It tells you to open up a file. Please make sure you go to the right place to open up the file when we start these. It says in the Chemistry with Computers folder. I think ours is just Chemistry with Vernier. I think ours is a slightly different name. Okay? Everything you need is listed. It's a relatively simple lab. What we're going to do is we're going to change the volume and measure the response in a pressure sensor. Please remember that you will be working with people you've worked with in the past. Put you in groups of 2, maybe 3, depending on the number of people here, the number of sensors. I can't tell you who you're going to work with yet until the actual day of the lab, because sometimes people don't come to school.
They're the volleyball girls.
You know, I know they are, but like, if he's not here,
You be
or
here?
if he's not, do you know what I'm saying? Like, I will wait till the day of to assign lab partners. You may be put in groups of 3 this time, just because I only have a certain number of gas pressure sensors. Be prepared to be the person who has the Logger Pro software on your computer that we will use, okay, just as we have in the past. Every one of you has it. And yes, you are prepping in your OneNote notebook. I'm gonna teach you how to do this already. So over here in our Canvas assignment, there's this thing called Class Notebook. Right? If you click that, it'll load you into OneNote. You're gonna hit sign in.
But it says for recorded.
What did you do?
That's weird. Mine's working.
Oh, sometimes it does it. You have to look. Alright, now we'll make you do some initial setup stuff. Now I'm gonna make sure that we get everything we need. There you are. So, when you log in, over here on the left is a couple of things. The big one is gonna be the content library. There's some stuff that you would be given. The lab handouts is probably gonna be your more useful, if at all, of all of these. Let me see if it loads. If it doesn't, I can always put stuff directly into the folder. There it is. Okay, so the big one here is the lab formatting handle. Okay, this thing tells you how to format my labs. And what that means is you're gonna prep under your name is where you can type. Under here is where you just kind of have things. What I'm gonna do is I'm gonna distribute this to you so that you have it in your actual lab notebook.
Yeah, that's exactly what you.
For what?
Like right now, I can fucking do it.
No, for what? No. Just for.
Do it. Yeah, it
Alright,
works.
so now let's go into your name and in our notebook. That should be showing up soonish. Since you're using the app, sometimes it can be kind of weird in connecting with the online. If it becomes a problem, it's the thing where we can open it up in like a separate thing. Okay? So what you're gonna do is you're gonna start a page, and this is your lab notebook. So you're gonna start a page, and you can always you're gonna title it the name of the lab. So this lab is Boyle's Law. The handout is on Canvas. Okay? And what you're going to do is you're going to go through and you're going to read this lab handout and you're going to prepare a lab in your notebook that you could follow along without needing the handout. Because on the day of, you'll just want to be able to use this. Now, what I told you in this actual, assignment was that here are the 6 or whatever sections you need, okay? The handout for the lab format has a bunch of things, right? Ignore anything that isn't the ones that are up there. So like you don't have pre-lab questions, so you don't have to do that. Okay? You're gonna write a purpose because this lab has an identified goal already. And then you're gonna write out the procedure you wanna do to make steps. Like in the actual handout, it's in like, it's in like numbers. Like that would be really good. I have people who use check boxes so that as they go through, they can check it off. Yeah, that's basically what you're doing. You're prepping lab. Okay?
Yeah.
Any questions? It's kind of weird, but it's my introduction. We used to do this all by hand. We used to do it in like notebooks and like do it by hand, and now we can do it online, which is nice.
It's a lot better than
Prep your lab notebook.